Hello, in this video we're going to determine if the series sum of nth root of 2 minus 1 n equals 1 to infinity converges. The first thing that I do if I want to understand whether a series converges or not, I try to understand the nth term of this series. So I'll start with nth root of 2 minus 1 and I get a feeling of how large this term is, because the understanding of convergence of a series is the same as understanding of how large the terms of the series is, so that we know whether the sum is large or whether the sum in fact converges. Let's look at, say, square root of 2 minus 1. How large is that? Well, you know, roughly root 2 is 1.4, so this would be 0.4, roughly 0.4, somewhere between 0.4 and 0.5. So if you look at cube root of 2 minus 1, that might be a little bit more difficult to understand. In one way of understanding this would be to multiply by its conjugate. So you are familiar with difference of cubes. X cubed minus y cubed is x minus y times x squared plus xy plus y squared. If you multiply this by the conjugate, that would give you 2 minus 1 cube root of 2 squared plus cube root of 2 plus 1. Now the denominator is not very difficult to understand. What we know is that the numerator is 1 cube root of 4 plus cube root of 2 plus 1. So roughly speaking, that's 1/3, because cube root of 4 is roughly 1, somewhere between 1 and 2. Cube root of 2 is very close to 1 and 1 is 1. So this is roughly 1/3, although this may not be a very good approximation. So you can look at, say, 4th root of 2 minus 1, multiply by the conjugate, you get 1 on top, 4th root of 2 cubed, which is 8, 4th root of 2 squared, which is 4, 4th root of 2, and 1. So again, this is roughly 1/4. It would be somewhere between 1/4, and if you consider these terms, these are between 1 and 2, so it would be somewhere between 1/4, and if you replace all of these with 2, you would get 1/7. So it's somewhere between 1/4 and 1/7. So how do we approach the problem now in general? So let me remind you an identity, which is a pretty useful one when it comes to solving problems. If you take the difference of nth powers, x to the power of n minus y to the power of n, you can factor that as x minus y, x to the power of n minus 1, plus x to the power of n minus 2y, plus x to the power of n minus 3y squared, all the way to x y to the power of n minus 2 plus y to the power of n minus 1. So if I look at nth root of 2 minus 1, I can multiply by the conjugate, so nth root of 2 minus 1 times nth root of 2 to the power of n minus 1 plus nth root of 2 to the power of n minus 2 plus all the way to nth root of 2 plus 1. And the denominator would be this sum, nth root of 2 to the power of n minus 1, nth root of 2 to the power of n minus 2, all the way to nth root of 2 plus 1. So the numerator is going to be nth root of 2 to the power of n minus 1, and the denominator is nth root of 2 to the power of n minus 1 plus nth root of 2 to the power of n minus 2, all the way to nth root of 2 plus 1. Now, of course, the numerator is 1, and the denominator is this expression. So nth root of 2 to the power of n minus 1 plus 1. So I want to understand how large or how small this expression is. So let's look at nth root of 2 minus 1. I know that every single term in the denominator is at most 2. So then this expression is more than 1 over 2n and is less than every single term in the denominator is at least 1. So if I replace all of them by 1, I would get 1 over n. So which one is going to be more useful? Well, of course, I know that the sum of 1 over n diverges. This is the harmonic series, n equals 1 to infinity, so it diverges. Therefore, the one on the right would help, in fact, better. Nth root of 2 minus 1 is greater than 1 over 2n, and both of these are positive. So now by comparison test, the sum of nth root of 2 minus 1, n equals 1 to infinity, diverges. And that brings me to the end of this solution. So at this point, I would like to propose that you work on this problem. Determine all constants p for which the following series converges. Nth root of 2 minus 1 raised to the power of p, n equals 1 to infinity. And I will work on the solution to this problem in the next video. If you have any suggestions and problems, feel free to send them to me at mathcompetitioncoach@gmail.com. And I will see you in the next video.